we are going to get right into it with a warm-up. The warm-up is going to cover a little review of what we've done before, and it's going to be tied in with what we're learning today. So the first question is up on the board. Take a few minutes to write down the answer to this question. There should be a little bit of review. Just kind of let me know when you're ready, kind of give me an idea of what we're working with. Alright, should be just about finishing up. Here's answers up on the board. A prime number is any whole number greater than 1 who can only be factors 1 in itself. So, can anyone tell me the prime numbers between 1 and 10? There are only 4 of them. Can anyone tell me that?
2, 3, 5, 7.
2, 3, 5, and 7, yes. And we are going to be working with those today as we are going into our lesson of monomials and factoring monomials. Alright, next warm-up question is up. And I want you to find the prime factorization of 30 and 15, so I want you to break it down to where you have those prime factors of 2, 3, 5 that make up these, and 7 that make up these numbers. Like I said, it should be a little bit of review. Maybe you're getting hit blindsided, but we will go over the answers in a little bit.
Could this scrap paper be used to bring up my tears?
Yes. 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 Alright, so I'm going to go to the answer now. So here's a prime factorization. So it's pretty simple once you see it and you kind of like understand the vocabulary and stuff. So prime factorization of 3 and 5. So 3 and 5 can't be broken down any farther than that. And then of course they make up 30, so you just multiply by 2. Next question. This is the final question. The GCF of 30 and 15. So if you don't know what GCF is the greatest common factor. So should be pretty simple, tied in with the last question. Alright, so here's the answer. Greatest common factor of these is going to be 15 because when you broke down the numbers before it, the numbers that I broke down to were 2, 3, and 5, and then the prime factors that made up it were 3 and 5, and you multiply those together to get your 15. Alright, so now we are going to be heading into our lesson. Alright, so that is right. Alright, so monomials. We're talking about monomials, not just numbers. So we're talking about, we're going to be talking about expressions that are made up of products of prime numbers and variables. So we're going to be talking about numbers and variables such as like 10 can be broken down to 2 and 5. And variables such as a, b, c, x, y, z. And then remember, if we have an a, b, c, that it can't have an exponent or raised to a power more than 1. So we can't have x squared, y cubed. We can't have anything like that. It's got to be x, x. Okay? So here's an example. We have over here, we have 20x cubed, y squared. So we want to factor this completely. And when I say factor completely, it means I want the 1. So I want to see a 1 here. So 1 times anything is going to give you your starting result. And then they broke down the 20 by 2 times 5. And then the x's were broke down, of course, x times x times x times x cubed. And then the final step, we broke down the 10 to 2 and 5. So this is going to be our completely factored form. Now, if you get out your piece of scrap paper, we are going to be doing some examples. I want you to factor these completely. I will answer them on the board once you have had adequate time to go over them. Remember, we've gone over the tree method for factoring. If you don't remember, I will be using an example. So, yeah. I'm going to start on the first one. So, like I said, the tree method is pretty simple. That's what I call it, the tree method. You're going to go like this, and so you find a number that you can, that's a prime number that's simple enough where you can't factor it down anymore. So I'm just going to go with 2. So then that's going to give me 2 times 20 will make up 40. So then we want to break it down even farther because this is 20 is not a prime. So I'm going to just divide by 2 again. So that's going to give me 10. So we got 2 prime numbers here. And then we have 10, that's not a prime number, so we got to go one more time to 2 and 5. And then don't forget about our variables. The answer will be, if when I say factor completely, remember I want that 1 there. And then these are going to be, your answers are going to be on the outside of the trees. So 2 times 2 times 2 times 5. Then our variables, we have 1x, and then we have 3y's. So that's our factored form for that one. Now let's go to the second one. Tree form, pretty simple. Divide by 2 because it's an even number. So we get 2 times 13. And then 13 is a prime number, so we cannot break that down any farther. So these are only 2 numbers that we're going to have. So we got our 1 and then our 2 times our 13 times x times x times x times y times y times y times y. So that's our completely factored form of these examples. We're going to be changing gears a little bit, but kind of associated with the same thing. We're going over the greatest common factor like we did in our warm-up. We want to find the prime factors. So we're going to be trying to find the greatest common factor of 2 monomials. So we did kind of in our warm-up, we did the greatest common factor of just numbers. So now we're going to not just be doing numbers, but letters and longer expressions. So let's just get right to an example. So we got, this is an example of 2 monomials factored. They're not going to factor completely because they don't have the 1, but they're factored. So what we want to do is once we factor them out, look at what terms are the same. So since they both have at least 1, 2, you take 1, 2. But since this one doesn't have a second 2, you cannot use this second 2. Notice how it's the same way, only in the opposite things. There's 2 3s, but you can only use 1 because there's 1 here. This is when you find the greatest common factor. So we have 1a and 1a and then the 2 b's. And then there's no c's, so we can't include that. So what we do is we take the ones that are in both, and then we put them down here, like our factored form, and then multiply them together to get our greatest common factor. Okay, so we're going to be using the same exact examples in our next example that we work on ourselves. So we want to find the greatest common factor of these 2 that we've already factored. So it should be pretty simple since you already have in front of you to find the greatest common factor of those 2 monomials. And when you're done, just give me like a thumbs up, or like if you can't get it, just give me a very confused look and I will help you. So make sure you circle the ones that are in each of them so you can not be confused about what you're doing. Okay, so how are we doing? Are we pretty much there? Alright, can somebody tell me the first number that we're going to have in our greatest common factor?
2.
2, right. So we circle 1, 2 here, and 1, 2 here. Can we do another 2?
No.
No, we can't because it's not in both. How about 5? Can we do 5?
No.
13?
No.
Alright, and then we're to our variables. X's, how many can we do of those?
1.
1x, right? And then how many can we do with the y's? 3, right. So, make sure we circle both. So, it gives us 2xy cubed. Good? Is everybody alright with what I'm doing? Alright, cool. Alright, now, the next part is